Hi all, welcome to my video. In this video, together we will be modeling this part. Let's start. We open a new part first, and then in the front plane, we will create a sketch. I will sketch something like this. Start here a line, continue like this, continue like this, and then I bring my mouse back to the point so I can have an arc. So then I stop. I select these two guys, make them a construction geometry. So I will here define some lengths. Here we have 100. Here we have 35. Radius are 200. And here we have a diameter of 55. So this is good. Then we close this sketch. We go surfaces, revolve surface, axis of revolution, and only a 90-degree revolution we will create. Then we say OK and close it. Look normal to front plane. Now here I will create another sketch. Then I pick a spline. Spline have only 2 points, one beginning, one ending. Then I drop this guy here. I take control points and move them a bit. I need a line. I place my line here. Then we will make here a tangency. And then I will start to give some values. Here I have a tangency value of 50. Here I have an 80. I will give here a height, which is 70, and offset from 5. So from origin 5 out. So we are missing something, which is a degree, which will be 20 for this guy. Okay, this looks good. So we close our sketch, and then we go to next sketch. In the front plane, we create another sketch. Now I will create 2-time spline. If I'm right, they were starting from here. One comes like this, another like this, and don't do like that. It is mistake because this is a midpoint, and then you cannot control your spline anymore. Good, because a midpoint will not allow you to freely travel as I do now. So I little bit move them, and then I will start to give some dimensions. So what we will do now, we will create 2-time line. Lines are here. Control pressed, line selected, tangent. Same operation here, tangent. So let's start to give values here, which is 25. Plus from here, 35. Here we have 45 degree, a 45 unit of tangency. Here 50. Same idea. Here we have 20. Here we have another 20. So this gives tangency. That's sine also, that's good. 80, 80. Here I need a 20. Yes. This is good. Here I will define lines. 2-time construction line. I drop a normal line and then convert them to a construction geometry. So I need to define here height, which is 8. Total length from here will be 85. So sketch is fully defined and everything constrained. That means we define all the dimensions, we give all necessary constraints. Why this is important? Sometimes I get questioned. Things will not be perfect in one go, so you will need to revise a lot. So if you do not constrain things with respect to each other, then you make changes, everything will be flying around, and then you will have a big mess in your part BOM. So feature tree, not part BOM, sorry. So we have, that's the reason why we do that. we have 3 sketches, one in, 2, one is out. You could do 3 in the same also. So we need here a split line, split one line with the help of sketches will break surface. There is another way. For example, you can select trim, standard trim, and remove the section. This also a little bit works same way. This depending on how you get used. So I select these two. I will select this. And if you look my operation, I need to do one more thing, which is delete face, because I need this area to be empty. And also here the only delete needs to be selected. Sorry. Redo again. Good. So we got this guy. It looks good. And I think this is the most difficult part. And from now on, everything will be easy. Here I create sketch in the front plane that I will create here. One arc. Select this one and look like this. I press my space keyboard and I will make this one little bit tangent. So I think a tangent. Oh, it was becoming tangent on my own, but maybe I made some little variation with my dimensions, but it's okay. Then I will give this value. Looks good. We close the sketch. Now we will work on the right plane. So in the right plane, I create a new sketch. I select an arc here. So we define an arc with 2 constraint points, and here our value is missing. We will give it 35. If you say how it look like, if you want to look from normal, you will see something like this. Okay, this looks also fine. We close this, and then we go to loft. I select the sketch, select this one, guide curves, right click here, selection manager. We are going to select these edges that we break with and the sketches. So you can do different ways also. For example, convert these edges a 3D sketch. That's also working. But since we have these edges, and I didn't need to do that one more time. This looks good, and we need to do now some mirrors. Mirror here, body is the mirror. 3 times body we have. Because part is symmetric in X and Y, I only use quarter, and that saves some time. Also, when you make change, this also makes your life really easy. So we got something like this. Mirror operation is done. What you need to do, select planes, and to the bodies the mirror section, select your bodies. Under surface bodies you can find here. So that's good. Surfaces, planar surface. With the help of this, I can close top because I want to have an closed volume to be able to convert this surface group to a solid geometry. I will use this guy here. I need an extrude with this mid plane. I made some extrusion. I have this. Now I will trim. Mutual will be active. You use mutual when there are several surfaces. Standard for only one surface, for example, or with a plane or with a sketch. So then I will select this guy as well. 3 sets of surfaces. I select yes, remove. This will be removed. This will be removed. The rest stays. This looks good. Now I can select this last one. If I select also in the same time a plane and click right to mirror, automatically that body will go to mirrors in the mirror section to the bodies. So merge solids, knit surfaces, I think better not merge solids. These 2 surfaces, for example, here knitted. Not knit the whole thing, but still fine. So then I will select the surface, select everything, create solid, will make solid, Merge entities will remove unnecessary surface breaks. I say okay. You see that unnecessary breaks that doesn't need to be there, it goes. They are for our own convenience. Sometimes we break in this kind of models. So this is good. In the front top plane, I will create a plane now. Let's do this first. Flip offset, 35 bottom downwards, bottom of our model. We create here a plane, and on the plane, a circle will be created. This is our circle. The diameter of that circle will be 50, if I remember well. Let's see. This is not an this is a tutorial. It's going to be an exact model. I created a 50 circle. Then I select both. Our option open where we can create some draft. This height was 120, and we have here some overlap, which is fine. Draft will be outward, so we have an angle. This is good. Also, what we did here, we create merge results. New body will be combined with the old one. So you see here only one solid body. So how we get rid of these guys? We go delete face, delete and patch will help us here to get rid of this unnecessary operation. You need to select everything that you would like to send and delete and patch active, and they're gone. So it looks fine. I can add here a fillet. Normally I always add at the end, but I can do it right now. 6. In the front plane, I will create a sketch. I will use this one to create here one another operation. In front plane, we create a sketch, and then we will convert the initial sketch with offset of 4. We created something like this. I was a little bit fast. If I wouldn't do that, normally during that offset, I could create also. I could convert the base sketch into a new constraint construction geometry. Sorry. So we got here a 10mm high sketch, and then I will have here an extend feature. I select this one, I extend it there. This needs to be trimmed. This can stay here. You don't need to trim this side. It is up to you. You can also make a rotation revolve like this, and trim feature will not be active. This is the section. This is the revolution, and then it's fine. Fillet here will be again now 4x4 if I'm right. We'll have here a smaller, 4x4 bottom, and let's make it here 2.5. Okay, and then here we create a sketch. That's a flat surface. We can create a sketch. So I draw here a circle, and this circle will be 25mm. I close my sketch, go extrude post space, 14mm length extrusion. Also here a fillet, 2.5. Now fine. So we are quite ahead. In the front plane, I will create another sketch. Here I will create one line. Then I will create this arc. Okay, then I will do something like this. Close this one and convert this to a construction geometry. This is tangent. Height of this 7. Okay, if you select the center line and a point, you can define that also diametral dimensions. Okay, we created this. It's okay. Revolve cut. This is the axis of revolution. We will have this nice cut there and 3 radius. whatever radius you define, if you want to have everywhere radius after shell operation, that radius should be bigger than your material thicknesses. Don't forget. This is a little bit exaggerated, but yeah, tutorial. Let's go ahead. Not so much importance right now. So we will create another fillet here, 3, here another 3. Okay, it looks fine. You could make it bigger if you want. 3 here, maybe here a little bit bigger, 5. I don't recall my model's values. Yes, 5 and 5. Which looks good. Look at that, it looks fine. So now shell. I will make it a little bit thicker model. I don't know what's the real thickness in such models. It gives me an error. I'll say okay, go ahead and create it for me. He created a shell and you can see inside. Do you have some sharp edges? Yes, here for example you have. Normally in the production these are not desired. This will have impact on the material flow when you create this part in injection or different metals. But yeah, this is tutorial, don't mind so much. There are so good books about these details for plastic part production and modeling. You can have a look. So if you come here, features and thread. I select thread location here. I will create a bottle thread. So the length is 9. I will create an offset of 1. Option is this. Before I made a video, so the settings are same. M6, M5 should have smaller pitch, or this was bigger, or M8 was, I think, smaller pitch. I forget it. Yes, we have this guy, and extrude thread will be. All the settings are good. We say okay. We have this nice shape, and here I wanna change some things, and I want this one to be a little smaller because I have interference with my thread, or you could make it shorter or bigger, but it's okay. So what we need to do now, in the right plane, create a sketch, and one more time, we need to look normal to right plane sketch. Create a sketch, take a line, and just drop here somewhere, tangent to this, so it's not like this. This was, I think, the center of thread profile. Yeah, you see. Okay, we can do it this way. A little bit move to this location and say to this one tangent. So I will use this line to create a plane. So this is good. And after this operation, I create on the surface a sketch, and from this line to this guy, I draw a sketch. Yes, this should be fine. And create the reconstruction geometry as well. Now what we can do, we can create a plane. This is really good. We created an inclined plane with the tangency to do this thread. Okay, so on this plane, I create a new sketch. Space clicked, look normal to, where is this guy? Here. So then I will create here an arc, starting from this point. Okay, here. Continues like this. And I will try to assign an by the way, my resolution is very low. That's also another problem. I think I need to also play with that. When model gets complex, SolidWorks starts to have this polynomial, polygonal shape of visualization to be able to use system resources efficiently. So, okay, we have 10, and I will not so much bother now. Normally I would make it everything fully defined, but let's keep it like this now. So important. So what we have here, a thread profile created by program and sketch. Normally, most likely, if you design some things, it might be the case that you create even thread profile by yourself. So features, space, sketch was selected, and it is automatically in the area. We got some errors. Most probably we have some issues with the sketch. We can do like this. We convert this thread profile, or we convert the surface. Let's do it this way. Convert surface, and then select this guy, and then this one. Still didn't work. I think we have some mistake. We need to go a little bit back. Let's do this way. Show thread profile. I will delete this guy now, right now. I will start from here with a sketch. Okay. From here, a line to the center. Not necessary to be at the center as well, but let's try. Let's give midpoint. Not giving. I think most probably appears. Oh, it's not as well. Anyway, let it be like this. This is good. We look from right plane. Okay, on the right plane, I will create a sketch, which will be exactly in this location. I drop it like that. I combine these 2 points. I set coincident. Look from this profile, this side profile. I select this one, select this one. These two tangency. So now we created plane again. That was the issue. Yes, it should work now. Let's try first. We need to do something different. It might take some time. I don't want to spend a lot of time of you. This is good. This is here. Let's try to create some tangency, but it didn't work. We will do like this. Then a line. Swap command is tricky. Always you have this issue if you do not have right points. So it is okay. I select a profile. I select new path. Yes. It is also good that you see somehow I tackle the things if I had a problem. So because we need to repeat it twice, I will not do the end, but I think the same idea, you can follow the end. And yeah, if you create here some little chamfers, it will look also nice. 0.5. State changing, and then you have this nice look. Yeah, this was it, guys. I hope you like it. I hope you can also follow. And we use a lot of commands, and I think also nice way to model surfaces. At the end also the model, it's very usual, and you see when you change display state, it start to look even nicer. You see, you can assign materials, not like this, but we have very plastic. So this is a tutorial, so don't take it literally, and you are allowed to make all kind of variations. Maybe you can come up with also better proportion in terms of length and diameter. I just in a half hour come up with this model and try to put everything together and prepare a tutorial. And yeah, thanks for watching. And if you like it, hit the like button and drop a comment. I will appreciate it. See you.